All right, pre-calculus 7-1, 7-2. We are just mixing up both 7-1 and 7-2 and spending a couple days on it. And it's solving systems of equations. So some of this is just repeat that you've had algebra 1, geometry, algebra 2. So you might be asked to use substitution, a method of elimination, or interpret the solutions graphically. So anyway, example 1, solve the system of equations. And it doesn't say how, so it's really your choice. I'm going to go ahead and just do substitution. I'm going to take this first equation and solve it for x. And so I'm going to get x is 3 plus y. And then I'm going to replace that for x in the second equation. And then you just distribute, collect like terms, and y is 2. But then you need to go back and substitute that into either of the two equations, but we have solved for x, so if I just replace y with 2, x is 5, and then your answer needs to be an ordered pair. You need parentheses and then box your answer. So you need to actually give the ordered pair as your final answer. Solve the system of linear equations. I'm going to use elimination, and that's where we are going to get one equation, or either the x's to be opposite in value or the y's to be opposite in value. And I'm just going to choose to get the y's to be opposite in value. It doesn't really matter, but they already have opposite signs. And so I want to use the same multiple, or I want to multiply them so that they are at the same multiple, which would be 10 and negative 10. And so I'm going to take equation 1 times 2, and I'm going to take equation 2 times 5. And so when I do that, there's equation 1 doubled and equation 2 times 5. And then I can just add, and the y's will drop out. And again, go back and substitute into any of the equations to find the other variable. I just chose the original top one, smaller numbers to work with. Subtract the 6, and y is 2, and so both x and y are 2. And there's your ordered pair. Seemed like a kind of nice start to a new chapter, maybe, I hope. Now, in example 3, I would prefer to get rid of the decimals myself. And so I am going to take each of these. They have at most 2 decimal places, so I'm going to take each of them times 100 and get rid of the decimals. If you have a system and say it's a 2/3 x plus a, 3/2 y equals 2, I would multiply both sides by 6 to clear out the fractions. I think there was a problem in the homework that were fractions, and people didn't think about clearing out the fractions so that they could just work with integers. So just FYI on that. All right, so then that means that my new system, I can get rid of those decimals. And then proceed to solve by substitution or elimination. And I would take equation 2 times 2, because the x's then will be opposite in value. So leave equation 1 the same. and we get y equals 3. And then again, go up to any of the equations we had before and substitute that in. And then just be careful to write the ordered pair with x first and y second. And before I turn the page, I just am going to come back up here and graphical interpretations of solutions. If there's exactly one solution, the two lines intersect at one point, and the slopes would not be the same. If there are infinitely many solutions, the two lines coincide, they're identical. There's one on top of the other, and the slopes are going to be the same. If there's no solution, the two lines are parallel, and the slopes are equal. So let's look at what happens on this next problem. Solve. And I would take this equation 1 times 3. So that then the y's will be opposite in value, or the x's. And when you go, both the x's and the y's fall out. And that means there are no solutions. There's no solutions. And it's because you have parallel lines. And we say that it is inconsistent when there's no solution. If there's at least one solution, we say it's consistent. If there's none, we say it's inconsistent. So on the last one, I'm going to multiply equation 1 by a negative 2. And in this case, you get 0 equals 0, which is always true. That means you have an infinite number of solutions. And the solution set is all points on the line. They are the same line. They coincide. They're one on top of the other. And that's it.